Hi everyone, in this example, a pole with 6 meters tall. So with these questions, we draw it ourselves. So this is our pole with 6 meters tall. Is adjust away from a, so this is our pole, is adjust away from a straight line. So ini tiang kita. And we are adjusted this pole away from this straight line. So this is our straight line with 20-meter height at the rate. So adjust away. So we are taking this one away. So means that this length is getting longer. So at the rate of 7 meters per second. What is the rate of the length of the pole shadow? So imagine this is your straight line. So when you're having light here on this pole, so this is the shadow. This is the pole shadow falling on the ground. So what is the length of this pole shadow increasing? So first, we identify our variable and identify the situations here. So situation here, look at like we're having triangle, and then the changing length, the changing variable here, the variable here is about the shadow, pole shadow. So x, we denoted it as the length of the pole shadow, and when we take it away this pole, this is the distance between the pole to the straight line. So just now we are adjust this pole away from this straight line 7 meters here. We are taking away with 7 meters per second. So therefore our rate of change of x will be equal to 7 ms minus 1. So 7 meters per second. So this is our rate of change. And then what they ask for? They ask for a rate of change of pole shadow. So they want the rate of change of x. So dx dt we are going to find. So our first information, finding the derivative form given and find out the question asked here. So from the step number 2, we have to identify the chain rule. If we finding dx dt means the variable x here will be linked with what kind of quantity so that it can respect back to time. So obviously we can see we have dx dt. So dx will be linked with the quantity s here. So dx over ds time with ds over dt. And we know that dx dt is already given. So our next step is finding out the equation involving the variable x and s. So the variable x here and s here. So what the situation we can see here, what kind of information that we can form here. So you can see you have two triangles here. So again with the similarity of the triangle, we can form out our equation. Look at the big triangle here. So the big triangle and the small triangle, they are having same 90 degree. As you can see, we are same having 90 degree, and they have the vertex which are same. So they have two vertex that are similar. So the big triangle with the base s plus x, height 20. So this is our big triangle. With the smaller one, with the base is x, the height is 6. So this is the similarity of the triangle. Then we can do our ratio here. So as our ratio here, we can see the base ratio to height. If we start base ratio to height with the big triangle, also the base ratio to height. So we try to express our equation in terms of x and s. So this is the equation. We simplify. So we can see this is 20x 6x plus 6x. So we can move it together. Actually, this is equals to 14x equals to 6x. So finally, x is equals to 3 over 7s. So the equation of x and s are obtained. Then we're going to start differentiate x with respect to s. So differentiate x with respect to x. So we get 3 over 7. Then lastly, number 4, we're going to substitute everything back to our chain rule in order to find dx dt. So dx dt equals to dx ds, which is 3 over 7 times dx dt. So dx dt, which is 7. So we get here is 3. So this is length of meter per second. So finally, do out our conclusion here. The length of the pole's shadow is increasing with the rate of 3 meters per second.